So recapping applications of GIS, definition of GIS. We also looked at the components of GIS. In fact, that's where we ended it. The components of GIS are hardware, software. I'm not going to ask you because I know by now you've ate some as you raised everything, you know. But remember, I remember everything that we've talked about, you know. So hardware, software, people are the brainware. Are you okay? The people who make it work, the users of the system. We need to consider them because you never design a system without considering the user. Are you okay? And so we also looked at the different hardware that is used in GIS. Okay. We touched on the plotter, we touched on the scanner, we touched on the digitizer. We need to know how all these things work. Okay. One of the most important hardware that is used in GIS is the computer itself. Okay. So we need to understand how the computer works. Well, actually not how it works, but let's understand the parts that, okay, this does this. What does a screen does? It helps us to display information, help us to communicate with the computer. We touched on the CPU, okay, which is actually housed on we can talk about the motherboard, okay, the motherboard. The motherboard contains the RAM. What is RAM? Random access memory. How is it different from storage? Storage is permanent. Random access memory is just temporal access of data on a computer. You need to understand a computer. You can't talk about an information system when you don't understand how a computer works. And so I always throw a challenge to my class when I teach that you need to have a computer. That's where you start from. In this class, if you don't know how to switch in a computer, you are totally out of place. No, you are not at the right place. What it means is that you're going to struggle because we are talking about a system, an information system. So the system should be able to spew out information. We should be able to query and get more information out. Okay, which also ties in with the definitions that we have actually given. Database definition, toolbox definition, organization-based definition, etc. I want you to understand what GIS is. In our first lecture, that has been the objective. And we carried it all the way. Talked about software, GIS software, what they are not, data attributes. Are you okay? And we said that we can actually have an object with several attributes. So the object and its attributes, which are really the properties of the object. And we said that we can have different types of attributes. Are you okay? Scales. We can talk about the ratio data. Okay, ratio data or ratio attribute scale. We can talk about interval data, nominal data. Okay, so these are things that we touched on, and I think we need to have it in mind that they are important. Obviously, today we want to continue and talk about, we want to get to know more about GIS, and one of the things that we want to talk about today, we want to start with what we call the metadata. So metadata is simply data about data. In other words, if you want to buy data, someone gives you data and initially they give you a metadata, then the metadata will tell you about the data. Is that okay? So it's like, I want to give you money, but I want to tell you what I'm giving you. So going to the bank and you get, I'm giving, the cashier is giving you money and then he gives you a breakdown of what they are giving you. Maybe I'm giving you 20 notes. I'm giving you 50 notes, or I'm giving you 50 notes. Are you okay? That is metadata. It's data about data. Are you okay? I want to know about the data. Are you okay? So give me data. So data about data. So metadata or data about data is intended to provide sufficient information that a potential user of the data can make an informed decision about the application and use of the data set. So you get to know, the kind of data you are holding in your hand so that you can decide what to use it for. Are you okay? So before you buy, normally the information you get is like metadata. When you go to a shop, you see that they've written, okay, this is a computer with this i7, this memory, is this storage, they're telling you about what you're about to get. That is what metadata is like, so that you will know that if I buy this is what it's going to do for me. Are you okay? All right. So the metadata can be actually grouped. You can group the metadata into different sections. You can have, excuse me, the data quality information. in one section. You can have the identification information, then you can have the entity and attribute information. So let's start with the data quality information. So what is the data quality information? What is that about? Okay, we talk about the lineage of the data. That means who actually produced the data, where has it been to? Are you okay? Sometimes you have data in your hand, someone gives you AutoCAD data, it's actually been edited. Are you okay? It's been worked on, it's been passed from one company to the other. You don't even know, do you? But you are holding it and you want to use it. Are you with me? So those who like copying, that's the danger. You never know what you are using. Okay, so the lineage of the data tells you where, what it has gone through, where it has passed, who has actually worked on that data. Originally, maybe it wasn't what you're actually holding in your hand. Are you with me? We can talk about logical consistency. The data has to make sense. You can't just have data that does not make sense. So you have data on roads. Are you okay? There should be, say, speed limits information with the roads. It should make sense. You shouldn't have things like 1,000 kilometers per hour. Maybe there's no car in the world that can travel that speed. Are you okay? So we need to understand that the data that we are given should have some kind of logical consistency. It should make sense. Logic is that's what it's all about. Completeness of the data means that we can't say we want data on Kaswa and then we've left out some part of it. Are you okay? We can't say this is Accra data and Kaneshi is not part of it. Are you okay? So we need to touch on that in our metadata. We need to tell about lineage, logical consistency, and completeness of the data. Identification information is part of metadata, and this section describes the internal use of the data set and any known limitations. So in other words, we want to tell you exactly what you are holding in your hand, that, okay, this data is for CAF students practicals. Okay, then you go and take it and use it for media projects. Then you are in trouble, isn't it? Because that is not what it's actually intended for. So we need to be able to identify the data and know that this data is for tests. Okay, for training purposes. Don't use it. All right, we'll find out in an example in a minute. So we should be able to have site information and other documents related to the data set as part of the identification information. In other words, if the data is coming from highways, that we need to know that, okay, this is from highway authority. So what does that do? It tells you the trust. It gives you some kind of, trust. You can believe that, okay, if I use this data set, I know it's coming from highway authority. I can trust it. All right, so that information is called the identification information. Entity and attribute information. Okay, this section provides description of the entity and attribute structure of the data set. Now I want you to look at entity and attribute this way. Entity will be the road itself. The attribute of the road will be whether it is tarred or not, whether it's first class or not, whether it has a speed limit of a certain value, are you okay, or less or more or less. So that is entity and attribute information. We need to get that. Are you okay? And he said that we need to know the range of known or permitted values. So I think I've touched on that a bit. Sometimes you are actually you are giving someone dates, data on dates, the date for maintenance, for example. Are you okay? So if you are dealing with buildings, then the date of maintenance of the building. Now, what values go into dates? You have to have values that look like, I think my board isn't ready. Let me just write here. So your value should be looking like something like this. So that is probably maintenance date. So the maintenance is due on 13th September 2027. So that data, this, are you okay, is what is permitted in the date field. Are you okay? We are looking at a database here. Are you okay? A table to keep information for the entity. All right. So we need to know what values are allowed. Okay. We need to know what values are allowed. Okay, then we have source of definitions for the attributes. So these attributes, they look more like, a table. In fact, most geographic data, GIS data, are arranged in the form of a tabular data. So later we'll talk about it, but I want you to know that we have to, keep that data. Yeah, every column in that table has to be kept in that order, in like a tabular format. Okay, in which every column describes a particular attribute, are you okay, of the object. Is that okay? So it's something like, it looks something like this. I think I need to share this. Okay, it looks more like this. So road ID, so the ID is here. The name of the road will be up there. Okay, the width of the road. So we are dealing with a road. Okay, so the road number 1, a road segment. So we're dealing with road segments. Okay, and so this will be Kwajo. So the name of the road is called Kwajo Street, something like that. The width is say 24.1. Are you with me? And then we are just moving on. So this is what we're talking about. Data is kept this way on geographic objects, in which this represents just one road segment. Are you okay? Now the so-called attributes that we are dealing with are the columns of this table. So these are the attributes. Okay, these are the attributes, and then we can tell the user that, okay, this column actually contains only numbers, real numbers. This column contains names. Then we can say date of maintenance. So date of maintenance. So we can keep date here. Are you okay? 24/1/2020. Are you okay? So this is the kind of thing that we are talking about over there, even though, you know, it's not, you don't see a table like that in there. That is what we're talking about. Source of definitions of for the attributes, the source of the definition. So in other words, when we say the width of a road, what do we mean? We need to provide all that as part of our metadata. An example of metadata is what you are seeing on the board. Okay, so coming up, trying to enlarge the screen. So metadata looks like what we see here. Okay, so here the data is coming from Environmental Systems Research Institute, Lineage. Okay, all right. So publication data, the metadata was made available. You can have, you know, the purpose, the intended purpose of the data. Is that okay? All right, so that's identification information. The data is simulated data set. It was created for instructional use. So you don't go and take it personal and use it for a UN project. Okay, so now this data can be sent to you before you actually buy the actual data. So we are not even talking about the actual data. It's all right. So that is metadata. So GIS, you know, sees this to be important because you can actually design the metadata before you actually go and even collect the data. Or you can use the metadata to purchase data. So there are two uses for it, for metadata. Okay, so that is it. Yes, it's one important topic that we need to talk about. Yeah, we're gonna move on. Unless you have a question on it, maybe as I'm talking about it, you are imagining, you can always ask a question on it. Otherwise, I think I will talk about something else. Excuse me. All right, so great. We'll be touching on this vector and raster. Okay, these are the basics of GIS. If you learn GIS, one of the things you should know about is the vector and the raster model. So as I'm talking from time to time, you hear me talking about a point, a line, a polygon, those things, they belong to the raster, the vector model, and the raster has got to do with picture. Anytime you hear me talk about a picture, like the scanner will give you, you know, a raster data set. So we will talk about the raster and vector model soon, but then the next topic is topology. Is that okay? If you don't have any question on metadata, which is data about data, we'll be talking on a new topic called topology. Topology. Okay. So topology. What is topology? You can see the lady and the gentleman. They all seem to be quite frustrated, isn't it? I think they are in a relationship and probably it's not working. But that's not what I'm here for. I'm not going to talk about this relationship. This is not the type of thing we want to talk about. We want to talk about.
Hello, sir.
Yes.
Hello?
Yes.
Sir, please, can you go further with the raster and the vector?
We haven't reached there yet. But
okay, sir, okay.
I'll be from time to time I'll talk about it, but you didn't realize that that's what I'm talking about. So I want your attention to come to the fact that it's the core of GIS, but we can't start talking about that but then it will come up soon. Is that okay?
Okay, sir.
Where we will talk about it properly. Yeah.
Okay.
Yeah. All right. So it's the next topic. I think so. Maybe the next topic. All right. So let's talk about, or the next two topics, that we'll be talking about. Topology. So topology is about relationship, okay, between geographic features. So topology is a relationship between geographic features. Topology. Okay, so what is topology? Topology refers to a spatial relationship between geographic features. Okay, so geographic features, example are wherever you are, look around you, look outside your building, all the things you are seeing, they are all geographic features. All right, so the relationship between them, one of the relationship between your piece of land and the person who is next to you is that you share a boundary. And of course, because of the disagreements and all that, we've had a lot of problems. All these things you are hearing about, the gas, all the problems they had. It's about relationship between geographic features. In other words, someone is saying your boundary ends here, it ends there. All those things are, a bit to establish a relationship that, there is a certain limitation to how far a geographic feature can go. So where your piece of land ends, someone's piece of land begins, and we always have that issue. So you can see how that has something to do with relationship. All right. So I want to just, go back to the board and then probably describe it more to you. I think you appreciate it more. Before I go to the theory, I'll go back to the board. So if you have, for example, a parcel of land, you can never have a situation like this. This is where, people start fighting. We can agree on a common boundary. It's all right. Now, because you cannot agree, so the relationship is suffering, isn't it? Because the two of them really desire to have a certain relationship that looks more like this. Where this line we have here is actually a single line and not a double line, as I've actually done, okay? So that is a relationship between two geographic features. What are the features? Then we are talking about a parcel of land, a plot, what we call a plot, okay? Americans also say plot. Okay, so I'm using this as an example, but you can imagine the number of possibilities that exist for relationships between two features. Now here's a T-junction. What is wrong? The problem here is that the two are not meeting. Are you okay? You are not having a relationship that you are supposed to have. So the relationship between the spatial relationship between geographic features, if you look at it carefully, you appreciate it. What should happen in a T-junction situation is that the road should meet it. If they don't meet, it means this is some kind of I don't know, a close. Are you okay? You've seen a road that goes and never comes back. When you go in one direction, you have to come back the same direction. Are you okay? So these two situations will be different, but meanwhile, it's just the relationship that has not been expressed well. Are you okay? All right. So there we go with topology. Is that okay? So it describes the relationship between connecting or adjacent coverage features. So they have to be connecting, they have to be close by together, those features. GIS that supports topology allows setting up topological rules. So there are rules. Are you okay? Just like a marriage, there's always a rules in a marriage. You don't do this, Kwame, you don't brush your teeth this way, and those are things that break the relationship. I'm not talking about relationship, but I want you to appreciate that it relates so much to it. You look down here in this diagram, you can see that polygon A and then polygon B, are you okay, have a certain relationship. They share a common boundary. Polygon C, same thing. Are you okay? All right. So let's look at the various components of topology. So if you want to really describe it, how do we do this topology thing? All right, we start with connectivity. So connectivity has got to do with the connection between lines or arcs. Is that okay? So the word arcs is used. So an arc, instead of saying a line, are you okay? So the line is looking more like a straight line. But anyway, it's the terminology, really. You can have a curved line, can't you? All right. So an arc or a line, are you okay? Their connection, how they meet. So all that will be handled by the connectivity component. Then we have the area definition. So you can imagine that the area definition has got something to do with the polygon. Are you okay? So another name for it is Polygon Arc Topology. We find out that a polygon is made up of different, a couple of lines, okay? Line segments that enclose. So we talk about that. And then contiguity has got to do with the direction of a line, an arc, the direction of an arc. So we are going to be talking about these three briefly. Okay, so connectivity has three rules. The three rules are points along an arc that define its shape are called vertices. In other words, when you have a line that seems to be bending, okay, really what you have is a set of points along the line that's defining the shape of the arc. You see this in AutoCAD all the time. Are you okay? So here, the line below is possible there are two, the more vertices you have, the more curved the line is. The more, the shape is kind of contorted. You have a more contorted shape. Is that okay? I want to use the word morphology, which is got to do with the shape. Are you okay? All right. Now, the endpoints of the arc are called nodes. The endpoints of the arc are called nodes. Normally, the beginning and then the end of the arc, we call them nodes. So that is part of what? The whole idea of connectivity. So nodes, okay? So the nodes actually move. We are talking about the beginning and the end. In between, we have the vertices. Is that okay? So vertices, this is an example of a vertex. That's another example of a vertex. So many vertices. So normally we'll have more vertices than nodes. Please, this is the whole idea of connectivity. All right, now the last one is very important. Arcs join only at the nodes. Is that okay? So if you have one arc and you wanted to join it with another, these two can only join where there's a node. So let's assume they have met at this point. According to the rules of topology, then we should find a node here. And at this point, this line should also have another node. So there are two nodes here which are connecting. So there should be a break for this arc. More or less, there are two arcs. You can't have more than one arc. So you have arc number 1. You can have arc number 2 here. Then you can have arc number 3. Okay. Now, what does it mean? It means that if this is one whole arc, then this is there are two nodes along it. So the rest are actually vertices that define the shape of the arc. I get that. You have more vertices here. Here too, you can have a few vertices. Okay, so this is the idea of connectivity. Is that all right? We are going to go on and look at the other one, which is containment. Is that okay? Area definition. If you have a question, get it ready. Okay, but don't ask it now. Maybe when I'm done with the topology, you can ask. Area definition has got to be polygons. It says an enclosed polygon has a measurable area. You can never measure the area of, something that is not a polygon, which is not connected, which is not enclosed. So I can have this. I can have that. Can I measure the area of this? No, I can't. Can I measure the area of this? No, I can't. Can I measure the area? No, I can't, because they are not enclosed. Are you okay? So we can't. Mathematically, the two lines will have to meet. All the lines have to kind of enclose like this. Then we are ready to go. And then we can now say, okay, now find the area of this. Are you okay? So that is the area definition, or the Polygon Arc Topology. Also, it says a list of arcs define boundaries. So these are arcs, okay? Arc number 1, 2, 3, 4, 5, 6. So there are 6 arcs that make up this polygon. Is all right. And closed areas are maintained. Okay, in fact, that one is like repeating, okay, reiterating on the fact or re-emphasize, the fact that the lines should enclose, the arcs should enclose. Polygons are represented as a series of coordinates that connect to define an area. I think we should need to also understand that. So there are a series of coordinates that, so in fact, if you want to define a polygon, all you need is a set of points. Is that okay? So you start with point number 1, 2, 3, 4, and then mathematically, what you are really saying is that this is a polygon, even though the lines are not drawn. The 4 points are enough to tell. So mathematically, you don't need lines to define a polygon. You need coordinates, okay, to define a polygon. So that is the containment rule for you. Is that okay? All right. The 3 rules of containment. Let's go on and talk about the contiguity. So contiguity is the concept that, every arc can have a direction. So we can actually associate a direction with an arc. In other words, you can say in this arc, the direction is from left to right or from right to left. So we go back to the board. The question will be, we have 10 minutes. So I think I'll be ending off on this one. So let's look at you sleeping on a bed. So everyone pay attention. This question goes to you. All right. My battery is low. So this you on a bed and you woke up at night. Please let me plug in my charger. Okay. So that's you on a bed. Okay. And your pillow is up here somewhere. Oops. Oh, don't do this to me. Okay. So you're on a bed and this is your desk. Okay. And you have a switch on your right hand side when you were sleeping. So you are facing up. When you are facing up, this is your right hand side. Is that okay? So this is your switch. Take note of the switch. Okay. And I said this is your table. Are you okay? This is the table. So you have your cup with a drink on it, and this is your bed. Simple setup. Are you okay? All right. So when you were sleeping, the lights were not off, but now the lights are off. Is all right. So you can all of you can unmute your mics. I want the answer to when you actually wake up, okay, and then you don't actually, you're not facing the same direction. Your head is now facing down. How do you know where the switch is? What do you do to find where the switch is? You can unmute your mic and then make an input. Is that okay? So when you wake up, oops, and then you are facing downwards, how do you know where the switch is?
Sir.
Yes, go ahead.
By turning right.
By turning right, the lights are off. Are you okay? When you were sleeping, the lights were, but now they are off. So you need to actually, or maybe even switch it off before you sleep. So how do you know you're right? Because you don't forget that you've dreamt, you've been moving, you've been tossing and turning in bed. And so now you've moved around. It's happened to, I don't know if anybody has experienced this before. It happens a lot.
Yes,
when you
sir.
struggle on bed, you can end up the other way around. Especially kids.
Yes,
children experience this a lot. And all of us have been children before. So if your head is now pointing downwards, how do you get to know where the switch is?
I said this because you know that is where your switch is always that you put it on. So no matter the situation, you know that even though it's dark, as soon as you stretch for your hand, you know that this is where the switch is.
But because your head is facing here, when you switch it, you expect that it to be on your right, right? Well, where would it be? Because your head is now here.
Your head is facing down. The moment you sit down,
listen first. I know the answer I'm looking. I know the answer I'm looking for. So listen first, so that you can get it right.
Okay.
If you are now facing down this way, when you're on your right hand side, you expect the switch to be here, but it won't be there, right?
Yeah.
So how would you know where the switch is now? when you actually touch on the right and your switch is no longer there.
Sir, should I come in?
Come in, please. Come in.
Okay, what I will say is, you see, when you're on the bed,
yes.
You know, these carpenters, when they mold the bed,
Okay.
where your head is, it will look funny, but I don't know whether.
They intentionally
when you
raise that
wake
part.
up,
Okay.
Yes, exactly. So when you realize that where your head is at the down,
Very
you will
good.
definitely identify where
okay. Exactly.
That's
So it means that your orientation is determined by what is actually next to you, isn't it? Sometimes what you can do is that, yeah, you get what I'm saying, because you are using that part of the bed to actually help you orient yourself. Are you okay? So the computer does the same thing. When the computer wants to keep a direction, if there's a line, it tries to look at what is on the left-hand side and then what is on the right. So if A is to the right and then B is to the left, which direction are we going? If A is to the right and B is to the left, which direction are we going? Are we going 1 here or 2 here? If the computer, the computer, in order to find out if this line, the direction is, to know the direction of this line, the computer keeps what is on the left or what is on the right of it. Are you okay? Then it gets to know the direction. So if what is on the left is B and what is on the right is A, which direction are we going? 1 or 2?
1.
Exactly. So the computer keeps a table, and then in that table, it keeps the left and then the right polygon. Okay. So if the left polygon is B and the right is A, then obviously we are moving in the direction 1. Are you okay? So that is how a computer is able to keep a direction on a line. Otherwise, it wouldn't know, because then it means the computer is too intelligent. But it has a way of tricking you itself. Are you okay? To know the direction. That concept is called contiguity. It's called contiguity. And it says that every arc has a direction. And the GIS maintains a list of polygons on the left and the right side of the arc. The computer then uses this information to determine which features are next to one another. Are you okay? All right. So when you look in this example down, okay, I think you can just try your hands on it. It's all right. So let me see if I can, we can try this. So let's all try this one. Let's try arc number 2. The direction indicated on arc number 2. So arc number 2 is the arc moving from, someone is going to look at the answer now. I don't want that to happen. Arc number 2, can you see it? Yeah. Can you see my cursor? That is arc number 2. Can you see my cursor moving? Okay.
Yes.
Okay, great. So can you see arc number 2, right?
Yes, sir.
Okay, what are the polygons to the left and to the right? Assuming that all polygons outside of this set of polygons are, the polygon outside of all these sets, the bigger polygon is called A. So the polygon, everything outside of all these polygons, the white areas, we call that polygon A. So in that case, what is the polygon to the left and to the right for arc number 2?
It's A and C.
Exactly. So A will be to the left, isn't it?
Yeah, A and C. Yes, sir.
And then C will be to the right. You got that right. Let's go to 3. Arc number 3. Let's try that.
Number 3. Okay.
So number 3, the arrow is going this way. So it means the flow is that way. It's flowing. The water is flowing this way. Yeah. Okay. So what is to the left? What is the right? I think the left is still A.
The left is D.
The left
is C.
I think the left.
No, it should be A.
The left is A, and then the right is D.
Okay.
Yeah.
Okay, let's try.
AD.
Let's try
Okay.
4. Arc number 4.
4.
Is this small one here? Is this small one here?
Is that the line?
It's a small line here, right? Can you see my
Okay.
my cursor moving? Eh?
Yes, sir.
And the arrow is
Yes,
going
sir.
down this way. So what is to the left? What's to the right? To the left.
Is it DC?
Yes, CD actually. So left is C,
Okay.
and the right is D. Yes.
D.
Okay, so this is it. It's okay. It may not even come in the exam, so don't worry about it. So that is how the
Okay.
yes. The thing is, sometimes we talk about this very interestingly in class, but I go to exam, it's not there. Anyway, so that is it for the 3 rules. And then please let's rejoin with the link. The time is up for this meeting. Let's rejoin and then continue. The next topic is overlay, map overlay, map, layers and themes. We're going to be talking about that in the next one. So if you have any question on topology, get it ready as